the first thing that they tend to list over here is the tech, right? So this is the tech that's being used underneath the thing. So when you see the word tree map, you know, hey, at the root of this thing, the data structure that's actually being used is a tree, right? So there is a tree under here somewhere. The second word that is used is going to indicate the concept that is being implemented. So in this case, the concept of a tree map is a map. Now, I hope some of you have heard about these before, talked about maps. Even in Python, some of your instructors might have covered this because Python has a thing called a dictionary. And in a dictionary, you can give it two things. I give it one word that becomes the lookup, and we call that the key. And then you can give it a second word, and that's the thing that you look up and return, and that's called the value. So you give it key value pairs, and then in the future, if you give me the key, I'll hand you back the value. Or if you say, is this key in there? I'll say, no, it's not, right? So dictionaries in Python are exactly the same idea here as a map in Java. Now, there may be multiple kinds of maps, right? There are hash maps, and we'll get into hashing later. There are tree maps, and there might be some other kinds of maps. But in this case, it is a tree, and it's implementing a mapping concept, right? Keys and values. Keys help us to organize things, and they allow us to have a fast lookup, and you say, hey, I have this key, what's the value that's about it? Ways that this can be used, give me the employee ID, I'll give you their name. Or give me the employee ID, I'll give you their salary, right? You can do a map that you can put in stuff like that. Give me a student ID, I'll give you a teacher ID of someone who is teaching them this quarter, whatever, whatever it is. So does that make sense? Hopefully everybody has covered at least the idea somewhere of a map, a hash map maybe, or a dictionary in Python. Hopefully that's not a hard concept or one that's completely foreign to you. But do you have any questions about that idea of mapping, right? It's take this thing and map it to this. Give me this and I'll look up that. And generally we want that to be fast, right? We don't want it to be this slow sequential search where you're looking through a whole bunch of stuff. So most of the tech that you find in Java is something like a hash map, and we'll talk about the speed. Hash maps are incredibly fast, right? Tree maps are pretty fast because we know trees are going to be log n, right? They're going to be log n complexity. They're going to be pretty fast. Hashing's faster. But the nice thing about a tree is because we know it's a tree, what else do you know that could happen? You could go and walk the tree and get an in-order thing, right? You could get those keys back in an in-order fashion. So trees maintain a sort of built-in ordering by their nature that doesn't really cost anything, right? When you add a node to a tree, it's pretty fast. And so a tree map, we kind of get the idea it's going to be organized, it's going to be pretty darn fast. And again, the idea is to map keys to values. Okay, any questions there? I'll take a drink because I'm talking fast today. So any questions there? Okay. So if you're going to go create a tree map, right, what would be the way that you do it? What are some of the things underlying that we'd have to know? Well, first thing that's interesting is they're going to be a double generic. We've never seen something like this before that has a double generic, okay? So in this case, you have to give it, and again, we're talking about tree maps, not our project yet, we haven't gotten there. But with a tree map, when you say, I want to make a new tree map, you have to give it two generics, two type parameters, because you can map any type to any type, right? Give me a number, of an integer, and I will pass you back a reference to a student. Or give me a textbook, and I will pass you back a reference to an author. Right? So it can be literally any data type. It can't be primitives, of course, because none of these can, but any wrapper type or any other object type. So you can map anything to anything else. You could map a student to a student to a teacher, a computer to I don't know, whatever, right? So they are double generics. And notice the convention here is that we use the letter K to represent the word key and the letter V to represent value. So in your code, of course, you can now not just have E's like we did before, but you can have places where you have K's and you can have places where you have V's. Does that make sense? So if we were to look at tree map methods, we would see that you can do things like, of course, course, clear the thing. But here's one of the typical things: put. Rather than saying add, a typical way to say this in a mapping type scenario is that you say, I want to put this into the map. I want to put in this key and this value as a pair. The mapping is going to be between this particular key and this particular value, right? This integer is going to map to this student object. So put is the same thing as add, but in a mapping sort of scenario. They let you remove things, and then notice in a lot of these things, if you just want to remove something, you don't have to give it the value. You're just going to give it the key. If you want to get one of the objects, you're going to give it a key, but you're going to get back a value, right? Because the whole purpose of a map is for you to give it the key and get back the value. It's a mapping scenario, right? You can say, hey, does it contain this key? And you give it a key and it'll tell you whether that key is anywhere in there, right? So it's kind of cool that you can get those things that way. And we can see the use for here, the double generic, right? Because sometimes you're talking about keys, sometimes you're talking about values, sometimes in them you might do both, okay? Yeah, Ben, go ahead.
But like, why would we use a hash, or why would we use a tree map over hash map if hash map is
because
faster?
we keep the ordering.
Oh,
right?
okay.
Hashing does not preserve ordering.
Right.
So if you ever did something like, I want to get the key set, right? In this case, we would expect that all of the keys are going to come back in order. Why? Because the keys are going to be stored in the tree, because the tree is how it's going to organize this thing to make it fast to find them, right? So keys are the organizing factor in the tree, but that's what it makes it fairly fast for you to give it a key and it to give you back a value. So if you needed to do this thing, we would expect this to retrieve something that is in order, okay? A set of values that are in order. Make sense? Now, if you don't care about the ordering, don't use this, right? Again, this is one of those thought things where you go, oh, if I just need it fast, but I don't care about the ordering of the keys, then I will use a hash map. If I care about the order of those and I want having to do extra sorting, maybe I'm going to use a tree. Right, and Sarah says, do we always need a key? And the answer is yes. You always will give it that pairing, because the key doesn't make any sense without a value, right? They always go hand in hand, okay? All right, what other questions do you have there?
So for things like contains key, contains value, and remove, I notice, and get actually, I notice that they take in an object instead of a K value specifically. Is there a reason for that?
Yeah, and I just stole this from somewhere in Java. I hope I stole it appropriately. I think what happens is, and I do not remember. I do not remember why that is that way.
Well, in that case, is it possible to design it so that it only accepts K?
Well, it would here, right? So that would make sense here, but they must have a thing where they can do, because a good equals method, right? A good equals method actually takes in an object parameter. So they're probably doing their comparisons based on equals, and therefore you can actually pass at any object, right? Because equals takes in an object. So that's my theory without thinking about it any deeper. That would be why, right? Because equals, when you call equals doesn't take a K, right? Equals requires an object parameter to be a proper overload, and that has to be Y here. Okay?
Understood.
Yeah. Okay. All right. Does everybody else see the most important thing here, please, is to see that the way that the tree is organized, how you're deciding whether things go left or right. Do I have a picture? I don't have a picture. So I need to make something different for a minute.